Thanks for having me today. My name is Sungjae Kim. I'm a postdoc fellow at Broad Institute, and I'm very pleased to share our recent work today. Firstly, what is MGIP? So as you know, abnormal plasma cell produce a single type of non-functional immunoglobulin, which is called M protein. And this M protein is detected by conventional methods such as ASPEP or immunofixation. And this level of M protein is very important for the diagnosis of MGUS or smoldering myeloma. And recently we used highly sensitive mass spectrometry to detect very low level of M protein that is not detected by conventional method. So we named this new condition as monoclonal gammopathy of indeterminate potential-MGIP. So the discovery of this MGIP led us to the key question: is MGIP just transient, or is it stable early stage of the disease? So to address this, we leveraged nationwide cohort to analyze more than 2,000 blood samples collected from 500 individuals who later developed myeloma or MGUS non-progressors. And firstly, what we found is MGIP was not transient. So 84% of MGIP in the people who later developed myeloma, they were persist for a year, more than a year before diagnosis, and some of them even increased to the MGUS level. And secondly, the progression pathway of each M protein was way more complex than what we thought. So we discovered multiple M proteins appearing and competing over time, and with one eventually becoming dominant. So this phenomenon, what we call is shifting dominance. And the shifting dominance shows us that there are multiple M proteins coexist and they evolve differently before myeloma. And thirdly, by applying single-cell sequencing, we have evidence that MGIP can be derived from clonal B cells or plasma cells with genetic alterations that can be linked to the myeloma or any other blood-related cancers. So this finding suggests that MGIP can be the earliest identifiable stage of hematological malignancy trajectory. So what does this mean for patients? So our finding shows that MGIP can be the earliest warning signal of the risk. So therefore, in the future, MGIP could help us to firstly identify the groups of people who need closer monitoring even before the traditional diagnosis. And it will also help us to predict who will be progressing to the myeloma. And ultimately, it can also help us early intervention, even before cancer develops. So by studying MGIP, we are actually uncovering the very first chapter of myeloma evolution, which will be opening door for early detection and better risk stratification, and also we hope prevention as well. Thank you.